Hi, I'm Neve, and myself and Jack will be presenting an overview of the project on improving COVID-19 contact tracing using machine learning. So, we're undertaking this project as part of our first year ML Labs training. So, as you all know, WHO announced a global pandemic in March 2020, and since then, there has been over 50 million confirmed cases of COVID-19 worldwide. Contact tracing is an essential process to help prevent the spread of COVID 19. So, at present, the HSE COVID Tracker app uses Bluetooth data to automate contact tracing. This has been a highly successful technology, but how can we use machine learning to enhance this accuracy?
Yeah, so as Neve said, the HSE COVID tracker just uses Bluetooth to calculate the distance between two people. So machine learning can use other information and data that the phones provide, like the other instruments in your phone, such as the accelerometer or the gyroscope, and that'll help us calculate more accurately whether or not people have been in possible contact with COVID-19 carriers through more advanced computational techniques. Areas where machine learning are already making an impact against COVID-19, and they're being used in screening, prediction, drug and vaccine development, and improved treatments. So, how did ML Labs get involved in this? NIST, which is the National Institute of Standards and Technology, which is part of the US Department of Commerce, in collaboration with MIT's PACT. PACT is the Private Automated Contact Tracing Research Group. They've provided a challenge called Too Close for Too Long. And this challenge aims to discover if two phones have been in less than 2 meter contact for more than 15 minutes by using data created by the phones. So ML Labs approached NIST and organized for cohort two, which includes me and Neve, to participate in the challenge. So since October, students from cohort two have been working in groups to compete in Too Close for Too Long challenge. And we've actually had access to a Google Collab group, which allows us to communicate with NIST and PACT directly.
So, we are focusing on the too close aspect of the challenge with the objective of calculating the maximum distance that occurs between two phones over a period of time. So NIST has provided us with data from a number of events. So an event is the data collected between two phones, the transmitter and the receiver, as you can see in the slide. And each event has a set number of features. So for example, the transmitter device and a receiver device, which is an iPhone X and an iPhone 8 in this case. But it also collects Bluetooth data and signal data over a period of time. So you can see from the middle table that it collects Bluetooth data, accelerometer, gyroscope, attitude, and gravity measures. And this has provided us with almost 25,000 events, where each event can be up to 20,000 rows long.
So the first thing that a lot of the groups did in cohort two in ML Labs was we created a baseline model to compare future efforts against um, our machine learning techniques. So you'll see on the right, a simple formula was used that just focuses on the Bluetooth signal to calculate the distance between two phones. So we have a reference signal and an environmental factor, which are considered constants for the formula. And then we take in the Bluetooth data from the phone. So in the table underneath, there's a sample here from 5 event files. We have the actual distance in meters, and then we have a calculated distance from the formula above, and then we have a difference in the calculated against the actual, and then a percentage difference. So the results are they're close in places, but they give grounds for further analysis and examination of why some perform better than others.
So other approaches involve converting the data gathered from the events to a wide format where machine learning techniques can easily be applied to. So some of these techniques include gradient boosting machines, random forest, neural networks, and time series analysis, while utilizing technologies such as PySpark, H2O, and various deep learning libraries such as Keras and PyTorch.
So there's four key areas that the groups have been asked to look at throughout this challenge. And the first one is teamwork. So not only are we working on our technical skills, but we're also working on our soft skills. So a lot of the students have come from very different backgrounds. Some people have project management experience or model development or evaluation and communications. So we're able to use collaboration tools as well through GitHub, Google Suite, Zoom, and Slack because no one's able to meet face to face, so we're all having to use online tech. So there's machine learning solution as well as the next part. So we're being tasked with building an end-to-end machine learning solution, including prototype, and we were expected to evaluate and test this software or machine learning solution. We then do presentations each month. We've been sharing our experience and what we've learned with each other through 15-minute PowerPoint presentations. And it gives us a chance to collaborate and ask each other questions that maybe our group haven't been able to answer. Then we do a final demo presentation and then we do a report. So the report will submit a comprehensive report on our machine learning solution. It includes exploratory analysis, explanation of the best solution that we've presented in the final demo, and then we do evaluation and testing. So that's everything from me and Neve. So thanks a lot for listening. And if you have any questions, please feel free to ask.